Morning, everybody. As you saw from the previous slide, my name's Ian Povey. I'm the DSO data manager, responsible for making sure that all our corporate systems have the appropriate data in there and that is accurate and timely. So where do we start with about distribution system operation? Like all good storybooks, I think I'll start with once upon a time. A distribution network, its function was really to take electrical power energy from the national grid and simply let it flow through its network to the end customers. We may have adjusted the voltage slightly, but really we just were making sure that the network was on ample capacity. And because things in the old days didn't change much from year to year, we were always able to reinforce our network in good time to make sure that we could deliver electricity to our end users. But things, the role and the requirements on a distribution network have changed dramatically over the last few years, and that trend is set to continue, with things like electric vehicle charging points, storage both at a domestic, commercial and industrial levels, solar PV, heat pumps, all these being connected to our network in ever increasing numbers means that actually we've got to be a lot smarter about how we run our network, how we control it. And that's the essence of distribution system operation. So going forward, it's not going to be as easy to work out what capacity we need, because it's no longer just capacity for demand requirements, it's capacity for generation as well. And the network power flows are flowing in all sorts of different directions, and that changes throughout the day. So midday, the sun could be shining, by the evening the sun's stopped, but its wind is blowing, or maybe not. So we've just got demand. So our network has to cope with an awful lot more. And we need to be fleet of foot in responding to this ever-changing environment. And that's why distribution system operation is different from being a pure DNO as it was in days gone by. So we now need to deliver capacity when it's needed at a good price as well. And that might mean that we need to reinforce, but reinforcement takes a time to do. So we may need we may need our customers to be flexible, or flexible customers to connect, to help us in that intervening period before we've reinforced. Or it may be that will be the enduring way that we operate our network in a particular area. And it will vary across all our network. So the requirements on us is much different to what it was in days gone by. And how do we achieve this? Well, really the key to the door is data. Without data, we're going into this blind. So we need data of high quality, not just for ourselves to plan our network, but we need to make that data available to our stakeholders and customers so that they can see what opportunities there are for them to contribute to distribution system operation. So these may be existing customers who can change when they want to take demand or when they want to generate to help the network, and they may get, financial recompense for that. It may be that the customer can look for places to connect. So it's not an existing customer, a new customer could come in and say, I can generate here, that will help you meet your peak demand, this, that, and the other. So things are really changing. So today's presentation from myself and my colleagues will be taking you through a lot of the data offerings that we're putting out there to help our stakeholders and customers understand what opportunities there are out there. And the thing I should really say for here and now is that what we are committed to doing in the ASW is to put flexibility first, to make sure that that is the first thing we look at to deliver the capacity that we require at the efficient price. So without further ado, I'm going to hand over to my colleague, Christos Kalounis, and he's going to take you through the first of our data offerings.
Tatos.
Thanks, Jan. So I'm Christos Kalounis, Capacity Strategy Lead with Electricity Northwest. Before starting, can I please ask everyone to mute your microphones for everyone that joined recently? I'm going to talk to you about forecasting and planning data. And there is three main publications that we share on an annual basis. First one is our DFES, which is a distribution of future electricity scenarios that present the forecast for electricity demand, generation, and battery storage across the whole of our EHV network. The second is Network Development Plan, what we call NDP, and this shows our network requirements for the next 10 years. And we also have the LTDS, our long-term development statement that presents a lot of data around network assets and also network requirements for the next 5 years. I'm going to present a lot of details around these three publications in the following slides, but what is important to highlight here is that stakeholder engagement is an important component of these publications. So what really makes the data that we share credible and improves their accuracy is that we go through a continuous cycle of engagement with our stakeholders. So there's information around their plans, the connections activity, and all that information from our stakeholders is incorporated into our forecast and planning data. And at the same time, our stakeholders use our data from forecasts and planning data to inform their plans. So it's really like a cycle, and this is really important, and it helps both sides to for our stakeholders to improve their plans, and from our side to improve the quality of the data that we share with stakeholders. What is important to note is that the data we publish through DFES, LTDS, and NDP is data produced through our standardized process for load-related investment. And this process is shown at high level here. In first step, we start from understanding our network in a better way. The way we do it is through monitoring. So we use measurements across 132, 33 kV and our primary substations. And moving forward, now we have more access to measurements across our low voltage networks and smart meter data. So we use that information and we combine it with information around connections activity, plans of our stakeholders. We also work with external forecasting partners that have expertise on consumer choice models that give us information around longer term forecasts for low carbon technologies like EVs, heat pumps, and distributed generation. And we produce our forecasts. And outputs data from these forecasts are presented in our DFES workbook, and these account both for the last historical year and also for 30 years in the future. Then these forecasts are used in network impact assessments to understand where and when we might need in the future to intervene and release capacity for the network. So this is the second step of our process where we try to establish the network capacity needs. The next step is to follow a flexibility first approach to define what intervention we need to release capacity. So we go through an extensive optioneering process where we identify the optimal reinforcement solution, and then we compare that solution with flexibility services through the local energy market to find the optimal solution. And the output is our load, what goes to our load-related investment plan. So information around the future network impacts and the options we consider for load-related investment are published in our LTDS and NDP. A couple of words around our forecast. In Electricity Northwest, we use our unique Atlas methodology, which is a true bottom-up methodology to forecast electricity demand, distributed generation, and battery storage. You can find more information online. DFES is a subset of the full range of forecasts we produce. And similarly to other DNOs, we need to highlight that it's important that we consider from local stakeholders not only data and inputs directly into the forecast, but also learnings that are generated from our continuous interaction with our local stakeholders. I'm not going to go into a lot of detail around the scenarios. Some of you might be more familiar with the scenarios used by DNOs in their DFES and also with the National Grid's future energy scenarios. It's more of a high-level view of the scenarios so that you can understand that you can get data from our DFES and NDP across a range of scenarios. On the left-hand side on this slide, you can see the 4 scenarios that are part of the common scenario framework between all DNOs and the ESO. So you can find these scenarios with the same names and the same high-level assumptions across all DFES published by the 6 DNOs in Great Britain and also with National Grid's ESO. On the right-hand side, it's the definition of the best use scenario that we adopt. It's been agreed through ENA's open networks that all DNOs are using a 5th best use scenario that aims to capture the highest certainty trends in a 1 to 10 years horizon, and beyond that horizon, it just uses a central assumptions in the longer term forecasts. So you can see what this best use scenario looks for our region. So we've identified that we are observing an accelerated electrification of transport. It's not the same for electrification of heating. We see more heat pumps, but we need to understand that a large part of our network is supplied by the gas grid, and where we don't expect to see the first adopters of heat pumps. And at the same time, we have some, let's say, average penetration of renewables and battery storage. So coming to the data you can find around our forecasts, there is a lot of information and graphs that you can find in our DFES reports. Electricity Northwest was the first DNO to publish a DFES. We did it in 2018, and you can find there information around electricity demand, both peak demand and energy, also distributed generation, so installed capacities, energy, information per generation type, and together with explanations around what are the drivers, so how what are the stakeholder engagement inputs in the forecast, what are the policy assumptions, what are the assumptions around technologies and fuel costs and efficiency measures and all that. But beyond the report, there is actually a workbook that becomes larger and larger through time because we keep adding more data as stakeholders. Our stakeholders inform us about what data they want to get. So you can see here at high level the different categories of data that we share. So for electricity demand, we share data like beyond peak demand, we also include minimum demand, which is important to understand maximum reverse power flows. Also information around energy, so annual electricity consumption, not only for the whole of the network or individual substations in the network, but also per component. So energy associated with heat pumps, EV charging, And the resolution that this data is provided is not only per local authority, let's say per council, but also per substation feeding area. So we go down to primary substation feeding areas, and you can see that we have more than 400 such areas. There's information we share also around distributed generation, so it's things like installed capacity, energy produced, and this goes beyond the main types of renewables that we have, that is PV and wind farms. It also includes things like CHPs, flexible generators, hydro, and other types. We also publish the new thing we publish is flexibility data. So we publish it for the full range of scenarios, and not only for maximum requirements in terms of megawatts, but also the energy requirements for flexibility. And beyond data, there are some useful visualization tools that you can use in this workbook. So you can find demand or energy across a single or multiple substations, and you can also identify the location of interest. So someone can enter the location of interest, and they can see what are the closest substations, etc. So we talk about a really large data workbook where we publish our forecasts. You can see the numbers here. It's nearly 300,000 data points. It's 34 different data sets that are presented into individual tabs on an MS Microsoft Excel spreadsheet. The resolution, as I said, goes to different levels, so you can find information per local authority, per council. You can also find information per bulk supply point, substation feeding area, by primary substation feeding area. And this data is both for the last historical year and for a 30 years horizon in the future. Data is for all our first 5 scenarios that I explained earlier. And you can see that it accounts for over 400 supply areas across Northwest. So these forecasts are used in network impact assessments, and they are also used to inform our load-related investment plans. So this information around future capacity headroom is in our network development plan. This is a new license condition for all DNOs, and we published our first NDP together with all other DNOs in May 2022, so earlier this year. In that one, you can find forecast of capacity headroom for both demand and generation across all scenarios and for the 30 years of forecasting horizon. Importantly, for generators, you can find capacity headroom for technologies that are connected, that is synchronous generators connected directly to the network, or technologies that are connected via inverters. And you can also find information around requirements for flexibility and reinforcement options to deal with identified capacity issues. There is more data around network assets that you can find in our LTDS. So you can find data around all circuits and all transformers. You can find data on fault levels. There is geographic and schematic diagrams. In our LTDS data, we go beyond what is a license requirement for LTDS. So you can find data, full half-hourly through year data for all HV feeders. So we talk about more than 3,000 HV feeders at 11 and 6.6 kilovolts. We also publish data on demand and capacity headroom across secondary substations. So we have over 35,000 secondary substations. So it's really a lot of data around network assets that cover the whole of our EHV12V network. And at this point, I'm going to hand over to my colleague, Gavin Anderson, who will do a deeper dive into the network development plan.
Thank you, Christos. So good morning, everyone. Yeah, my name is Gavin Anderson, and I am the EHV Compliance and Planning Manager for Electricity Northwest. I'm going to look to cover through the next 10 slides, which over the next 10 minutes or so, which cover the network development plan, but also a few little bits around the network asset viewer and heat maps, which I think are in this section as well. Feel free to drop any question in the chat and pass on any feedback, as this is always most welcome from all participants. The network development plan focuses on the network development reporting and provides the user with a valuable additional information on key projects which are set for delivery in terms of new infrastructure to be installed and upcoming flexible service opportunities. Information is provided with the objective of giving users that foresight of what the NW network plans are that may impact possibly their own developments or where they may want to focus the developments themselves, and also signpost that requirement for flex services. So users can target their developments accordingly to work in with our network. The high-level plans for network interventions and flexible service requirements within the NDP specifically cover the years that are required for these. So sort of looking at 10 years in the future is the sort of the scope of that. Location of that intervention, covering the whole network down to primary substation HV bars. Development required for flexible services and new infrastructure. See the tables in here, we'll come on to them in a moment. Justification for the need for these network developments as to what's driving that need and where it resides in the delivery life cycle. So we signpost that. Is it an approved plan that we're working on? Is it something that's in delivery already? Is it something that's further down the tracks? The report's broken down by grid supply point, and with the main feeding areas to the document covering approximately 70 pages across in total, with all 17 of our grid supply points covered there in the document. You can see on this slide here the feeding area for this site is broken down there, and you can see roughly where that feeds out to. So that map entry overview shows those feeding areas, and it picks out the specific sites within that area that require an intervention and the time frame that intervention is required from, and signposts back to our forecast data. These details include the need, when that need first occurs, how large that need is. We also include a very high level typical asset type solution that we've probably sort of come up with in our design team, as well as that overview of the level of flex response required dependent on the specific scenario that we follow. The NDP is further complemented by a workbook, which is effectively a nice Excel spreadsheet with a number of tabs contained within it. The opening page gives the users an overview and links to all the subsequent tabs. We've recently included a local authority indicator tab, which allows users to identify sites by local authority, which is something we responded to some feedback that we got in our consultation phase. To use the workbook, once you've identified your site, you can simply use the drop downs, which are just tagged at the top here, and the customers can simply drop down to identify the specific site that they're interested in, and the arrows then point accordingly. Information is then given out across each scenario, showing when likely interventions are required at that location, and this is also broken down by whether that be a demand issue or a generation issue, which is also within the workbook. I think the next slides go on to talk about our network asset viewer. So I only have one slide to cover network asset viewer, but this is a tool that we have on our website which allows users to gain a detailed map overview of all of our assets. These are searchable by substation, postcode, grid coordinates, and so on. This allows connections customers potentially to search in detail on our cable and plant records to facilitate their own network planning activities. This can be very useful for people looking to build out new developments, as to see what assets we have in the area and the likely capacities that may be within those, and allows prospective connections customers to maybe facilitate their own network planning activities at a high level stage before coming to us for an application, for example. The next set of slides covers our heat map tool. So at present, our heat map tool we publish on our website allows users to undertake a very high level feasibility assessment for connections on the 6, 6, 11 and 33 kV networks. The data in the workbooks are also linked back to a web interface which allows for a map and geographical overview of the data that's presented within the workbooks, and you can hopefully see that there on the right hand side. The data is based on an estimate of spare capacity at each of our bulk supply and primary substations. This capacity is estimated through a very high-level assessment of typical network constraints, including thermal loading of circuits, plant and fault levels, voltage step conditions, and so on. Worth pointing out that the 132 kV network is not included in this assessment, and also the effect of mesh substations is not considered, and that's something that would be teased out when you come through into a detailed assessment that members of my team would likely carry out should you decide to go forward with the project. The capacity is available, of course, is dependent on the type of connection required, and again, the tool covers a wide range of demand, generation, and storage types, and some typical sizes of connections onto our network are there on the slide there. We cover some scenarios around generation as to whether it be synchronous types or asynchronous, battery storage, and demand under N-1 or N-0, so firm or non-firm type connections. We also include a sheet within the worksheet which covers the heat mapped information for our Appendix G data, which is the status at each of our grid supply points. This is effectively the capacity for new generation connections is available at each grid supply point in turn. We also include a short overview of the project progression status at each of these sites, which is when a GSP has effectively run out of headroom and NGSO must then carry out a detailed study to determine the next steps to permit a connection. With the current high volumes of DG applications we're experiencing on our network at the moment, the system, there's present a number of our sites are in those project progression statuses where we're either awaiting feedback from the SO or in turn waiting to put in a further submission to get some more DG connected onto our network. And that is a very quick overview there, and I shall, I think, hand back to Christos next, who's got the next section.
Thanks, Gavin. And next section is around local area energy planning and our direction of travel around what data you should be expecting to get from our side in the future. So why do we talk about local area energy plans? These are very important for the UK's transition to net zero. If we want to optimize that transition, there is not one solution for all areas. We really need to make sure that every area makes there are specific characteristics that have the potential to support more towards net zero. So we expect that local authorities are the creators and coordinators of local area energy plans, and our role as a DSO is to support these LAPs and also facilitate these LAPs. So in other words, release capacity where and when needed to facilitate all plans around electrification of transport, heating, installation of more renewables, etc. What you can see here is a flow chart that has been standardized across all DNOs and within ENA's Open Networks project across all network companies. It's planned to be put in the LAP guidance. So this helps everyone understand how our load-related investment process produces data that is shared with local area energy planners, and at the same time there is the action plans that come from LAPs that are a direct input into our forecast and our consequently into our load-related investment. So you can see that DFES published following engagement with stakeholders is shared with LAPs, and they can be used as forecasting inputs to inform the LAP action plans. The same applies for capacity headrooms across all scenarios. This is published in our NDP, and this can be used as technical inputs to produce action plans. When we talk about action plans, it needs to be highlighted that we are not investing on our networks based on ambitious plans that we don't see enough evidence. So when we talk about action plans, we really talk about mature plan developments where we can assign a high certainty, and we for example, where we can see that there is secure funding for these projects, there is strong backing from central or local government, or there is also ongoing development. The other thing that is important around local area energy plans is that through the flexibility services that we publish, we help support and establish local energy markets. So we give the opportunity for local stakeholders to provide this flexibility and get revenues. And at the same time, this helps us reduce the bills for our customers because we can release the required capacity at a reduced cost. So what's the direction of travel around forecasting and planning data? What is coming soon, plans to be published in March 2023, is our HV heat map. So this is going to be a heat map that shows all secondary substations on a map, at the same time all circuits at HV, and one can find the demand and capacity headroom across all HV feeder sections, across all 11 kV and 6.6 kV circuits, and also the same for all secondary substations. At the moment, we don't have access to measurements across a large amount of our downstream primary substations in our HV and LV networks. So mostly this data will be around estimates. But moving forward, this data will be improved to consider measurements. It's useful to note that at the moment we are installing a large number of monitoring devices across secondary substations. We've installed it across 3,000 substations at the moment, and the plan is to install another over 8,000 within Rio 82. Beyond March, there is the plan is to publish interactive heat maps that will allow stakeholders see information around forecasting and planning data across the whole of our network, so from EHV down to LV. It's also be data that considers monitoring data from these LV monitoring devices and also from smart meter data. And it's also we're also going to publish more forecasting data across lower voltages, so we'll go down to the LV networks. So this was my part. I'm handing over again back to you, Ian.
Thank you, Christos. I'm now going to talk to you about the embedded capacity register, which we've now been publishing for nearly 3 years in different guises. The embedded capacity register started out as a system-wide resource register, and that was put together from work or initiated by work undertaken in the open networks and projects, which all distribution network operators contribute to. So we published the system-wide resource register for all generation above 1 megawatt from January 2020. At a similar time, the VAIS panel of technical experts wanted to know more about what generation was connected to our network. This was in relation to the capacity market and to be able to accurately forecast what generation would need to be dispatched. You would need to also know what generation was happening on the distribution network operators' networks. So the DPC 350, which is a modification to the CUSA, which is the connection code for anybody wanting to connect to the distribution network. The change to the CUSA was brought about by this proposal, and what it did was built on the system-wide resource register, but added more data points in there to help with the analysis required for the capacity market. So that's where we are as of today. And as I say, that embedded capacity register only at the present applies to generation that is at 1 megawatt or above. There is another diffuser change proposal going through the books at the moment, which intends to extend the embedded capacity register down to anything that's 50 kilowatts or above. So we anticipate that the user change proposal will be approved in February next year, and then we'll look to publish that extending ECR in March of 2023. And also at the moment, the embedded capacity register is just access to an Excel spreadsheet on our website. We've all agreed as DNOs that we will extend this, and we will actually make it available via an API. And we're hoping that the existing above 1 megawatt one will be available from January 2023 via an API. So that's the approximate history of the embedded capacity register. To work, and I just want to quickly take you through what is actually in that capacity register. As I said, it's a record of all generation and flexibility providers. So it could be a record of a demand customer offering flexibility. At the moment, those customers are above megawatt, but we're going down to 50 kilowatts. And one thing to say, we'll produce a lot of data. We'll tell you the name of the generation, where it is, coordinates of it, what size of generation or flexibility is on offer, and where it is on the network, as well as where it is geographically. The name of the generator or flexibility provider is obviously subject to the general data protection regulations. So if it's an individual, that name will be redacted. But otherwise, if it's a company, that name will be there. Not only do we tell you what is connected, we also tell you what is accepted to connect. So where somebody made an application to connect, or an application to provide us with flexibility services, we will tell you that we've accepted that. So it may not be on the system just yet, but it will be in the near future. And Electricity Northwest, and when the system-wide resource register started, there was always an area of planned reinforcement. Electricity Northwest are the only DNO that not only tell you reinforcement associated with a new connection, they tell you all our plans for reinforcement on the HV and EHV networks and above. So you can see that on our website right here and now. So that is really a quick potted history of the embedded capacity register and what it contains.